Every morning you wake up knowing that the floor will support your weight. You know that the sun will rise. And you know for sure that your body will not fall apart into elementary particles at any moment. But is that really the case? Deep underground, sensors at CERN are beginning to pick up signals that indicate that this is not the case. We are discovering particles that are too heavy to exist in a stable universe. We are observing gravity disappearing in dimensions we cannot see. We find things in the laws of physics that, according to our data, should not exist at all. This video discusses 7 specific anomalies that indicate that our reality is much more fragile, much more artificial, and much more dangerous than we were taught in school. So, for the last 50 years, physicists have relied on a rule book called the Standard Model. It is the most successful theory humans have ever written. It predicts everything. It tells the sun how to burn, it tells atoms how to stick together, and it tells us exactly what the universe is made of. It is supposed to be perfect. But recently, a massive laboratory in Illinois decided to stress test that rulebook by weighing a specific particle called the W boson. What is this particle? You can think of it as the spark plug of the universe. It is the carrier of the weak nuclear force, which is the force that allows the sun to fuse hydrogen into helium. Without the W boson, stars wouldn't shine, radiation wouldn't exist, and the atoms in your body wouldn't hold together the way they do. It is a critical, load-bearing beam in the structure of our reality. We know with absolute mathematical certainty that this particle has a strict weight limit. According to the blueprints of the Standard Model, it must weigh exactly 80,357 mega-electron volts. If it is any heavier or any lighter, the math stops working. The symmetry breaks. So for 10 years, scientists slammed trillions of particles together to weigh it. They checked and double-checked the data. And the number that came back wasn't 80,357. It was 80,433. Why does a tiny difference of less than 1% matter? Why should you lose sleep over a rounding error in a subatomic particle? Here is why. Imagine you walked into your living room with a tape measure. You measured the distance between the walls and you realized the room is 2 inches smaller than it was yesterday. You know you didn't move the walls. You know the neighbors didn't move the walls. The house looks exactly the same. But the measurement says the room shrank. How is that possible? The only explanation is that there is something invisible pushing against the walls from the outside. That tiny difference in measurement proves that the structure of the room is under pressure from something you cannot see. It implies that there are hidden particles or hidden forces interacting with our reality and leaning on the foundation of the universe. But if the foundation is under this much pressure, what happens if it gives way? This is where the extra weight of the W boson stops being a curiosity and starts being a threat. This anomaly suggests that the vacuum of space isn't as stable as we thought. We call this the problem of the false vacuum. Think of it like a ball resting on a ledge. We assume that our universe is sitting at the very bottom of a valley, the lowest, safest energy state possible. We feel safe because nothing has changed for 13 billion years. But this new data implies that we are not at the bottom. We are stuck on a ledge, halfway down a cliff, and the extra mass of that particle is tilting the ledge. If the rulebook is wrong about the weight of the W boson, what else is it wrong about? Are we actually safe on this shelf? Or is the floor beneath your feet waiting for a single, random trigger to crumble and send us sliding down into the dark? Could this be a mistake? Could a sensor at Fermilab have malfunctioned? Could a software bug have corrupted the data? That is the first question any rational person asks. But you have to look at who is holding the tape measure. This experiment wasn't done by a few students in a basement. This was the CDF collaboration. It is a team of hundreds of the best physicists on Earth, analyzing data from the Tevatron particle accelerator. They spent 10 years trying to prove themselves wrong. They tortured the data. They calibrated every wire and every line of code to eliminate human error. In physics, there is a strict threshold for claiming a discovery. It is called 5 sigma. If a result is 5 sigma, the chance of it being a random accident is 1 in 3.5 million. That is the level of certainty we use to confirm the Higgs boson. It is considered proof. But the anomaly with the W boson, the extra weight that shouldn't be there, that wasn't 5 sigma. It was 7 sigma. The odds of a 7 sigma event occurring by accident are roughly 1 in a trillion. If you flipped a coin and it landed on heads 40 times in a row, you wouldn't call it a coincidence. You would say the coin is rigged. That is exactly what this number tells us. The machine isn't broken, the math isn't broken, the universe is rigged. This result is a smoking gun that proves the standard model is missing a massive piece of the puzzle. It implies that the empty space inside the atom isn't empty at all. It is teeming with something heavy, something active, and something invisible that is putting its thumb on the scale. For decades, we hoped that a theory called supersymmetry would explain this. We hoped that for every particle we know, there was a heavy partner particle out there balancing the equation. We thought supersymmetry would be the neat, elegant answer that fixed the map. But the Large Hadron Collider at CERN has been smashing protons together for years, hunting for these supersymmetric partners, and it has found nothing. Zero. So we are in a situation where the W boson is too heavy, which proves hidden particles exist. But our best theory for what those particles are has failed completely. We are flying blind. We know there is an invisible elephant in the room because the floorboards are creaking, but we cannot see it, and our cameras aren't picking it up. So, if the standard model is broken, what does that mean for the stability of the world you see around you? If the blueprint is missing a page, maybe we are missing the warning label that tells us the expiration date of the universe. Because when you combine this extra weight with the mass of the Higgs field, the graph doesn't show a stable valley anymore. It shows a trap. To understand what this trap looks like, we have to look at the energy field that holds you together. It is called the Higgs field. You can think of it as the background static of the universe. Every particle in your body interacts with this field, and that interaction is what gives you mass. Without it, you wouldn't be a solid object. You would be a cloud of radiation moving at the speed of light. For decades, we knew this field existed, but we didn't know its strength. We didn't know how stable the floor really was. But in 2012, we finally caught the Higgs boson and put it on the scale. We got a very specific number, 125 giga-electron volts. Physicists look at that number, 125, and they get very quiet. Why? Because the stability of the entire universe depends strictly on that weight. If the Higgs were a little lighter, say 120, the energy field would be solid. We would be sitting at the bottom of a deep valley and nothing could move us. We would be safe. If the Higgs were much heavier, the field would have been so unstable that the universe would have collapsed billions of years ago. Stars and galaxies would never have formed. But 125? This number sits exactly in the middle. It puts us in a gray zone. It implies that the universe is stable enough to exist for a while, but not stable enough to last forever. We call this metastability. It means we are not at the bottom of the valley. We are stuck on a shallow ledge halfway up the cliff, and the wall that keeps us from falling off that ledge is not as high as we hoped. So, if we are stuck on this ledge, what prevents us from sliding down? In our everyday world, you are safe behind a wall unless you have enough energy to climb over it. Gravity holds you down. But the Higgs field doesn't follow the rules of the everyday world. It follows the rules of quantum mechanics. And in the quantum world, walls are not solid. If a subatomic particle hits a barrier, it doesn't always bounce off. Sometimes, it cheats. It borrows energy, disappears, and tunnels right through the wall to the other side. Since the vacuum of space is just a quantum field, it can do the exact same thing. Because the mass is 125, the The wall holding our universe in place is thin enough to tunnel through. We don't need a massive collision to push us over the edge. We don't need a disaster. We just need probability. If just one tiny point in space, anywhere in the cosmos, randomly fluctuates and tunnels through that barrier, it instantly finds the true vacuum on the other side. The moment that happens, the floor drops out. The energy state crashes to the bottom of the cliff. So the W boson anomaly tells us the ledge is tilting, and the Higgs mass tells us the wall is full of holes. We are living on borrowed time in a system that is mathematically designed to fail. But what does it actually look like when the loan comes due? If the vacuum collapses, do we see an explosion? Do we feel the heat? Or is it something much faster and much quieter? So, a tiny point in space tunnels through the wall. It drops from our false vacuum into the true vacuum. What happens next? You might expect an explosion, like a nuclear bomb going off. But this is much worse than a bomb. A bomb just rearranges matter. This event rewrites the rules of matter itself. Physicists call this event bubble nucleation. Think of a glass of supercooled water. It is liquid, but it is below freezing temperature. It wants to be ice, but it needs a trigger. If you tap the glass, a crystal forms. That crystal expands instantly, turning the liquid into solid ice. The vacuum collapse works exactly the same way. The moment that point in space drops to a lower energy state, a bubble forms. But inside that bubble, space is not space anymore. It is a different kind of reality. The laws of physics, you know, how atoms bond, how light travels, how gravity pulls, are determined by the specific energy level of the Higgs field. If you change the energy level, you change the laws. So, as the wall of this bubble expands, it doesn't just burn things, it fundamentally alters them. What happens to an atom inside that bubble? The protons in your body are stable right now because the current laws say they have to be. But inside the true vacuum, the parameters change. The strong nuclear force might become too weak to hold the nucleus together, or the mass of the electron might suddenly change. This means that chemistry itself becomes impossible. If this bubble hits the Earth, the planet doesn't explode. It simply ceases to be Earth. The atoms that make up the rocks, the oceans, and your body would instantly dissolve into a fine mist of subatomic particles, or collapse into black holes, depending on the new math inside the bubble. It is a total hard reset of the operating system. And once this bubble starts growing, it feeds on itself. The energy released by the collapse pushes the wall of the bubble outward with infinite force. It swallows everything in its path, rewriting the universe one galaxy at a time. But if a galaxy a billion light years away collapsed yesterday, would we know about it? Would we see it coming? This is where the laws of physics play their cruelest trick on us. It is about speed. In our universe, there is a strict speed limit. Nothing can travel faster than the speed of light. This applies to matter, but it also applies to information. If the sun exploded right now, you wouldn't know it for 8 minutes. You would see the sunlight, feel the warmth, and be totally happy for 8 minutes, while the death wave traveled toward you. The wall of the vacuum bubble moves at exactly that speed. Because the collapse releases massive amounts of potential energy, the bubble wall accelerates instantly to the speed of light. And this creates a terrifying problem for the observer. Light is the only way we can see anything. It is the messenger. But in this case, the killer is moving at the exact same speed as the messenger. This means you cannot see the bubble coming. If a vacuum decay event started on the moon right now, you would look up at the sky and see the moon. It would look normal. The light from the moon is traveling to your eye at 186,000 miles per second. But the wall of erasure is chasing that light at the exact same speed. The photons carrying the image of the safe moon would hit your retina at the exact same instant that the bubble wall hit your body. There is no warning. There is no siren. There is no time to say goodbye. One moment, you are sitting there, breathing, thinking, watching this video. You are fully conscious. The next moment, the structure of your atoms is rewritten. Your neurons dissolve before they can even process the electrical signal of pain. You don't die, you just stop. This is the ultimate stealth predator. It could have happened in the Andromeda Galaxy 1,000,000 years ago, and the bubble is currently rushing through the void toward the Milky Way. We would still see Andromeda shining in the sky tonight, unaware that it has been gone for eons. This makes the universe feel like a very dark room. We are assuming the walls are still there because we haven't been hit yet. But if this is possible, if the math allows it and the speed hides it, why hasn't it happened yet? The universe is 13 billion years old. If the floor is so fragile, why are we still standing here? Is it luck? Or is the math telling us something even stranger about the ground beneath our feet? So, if the vacuum is unstable, and the trigger could happen at any moment, how likely is it? To answer that, we have to ask a question that sounds stupid, but is actually the hardest question in physics. How much does nothing weigh? Take a box and pump every single atom out of it. Remove every photon of light. Shield it from radiation. You have a box full of absolute nothingness. Does that box weigh zero? Your intuition says yes, but quantum mechanics says no. According to quantum field theory, empty space isn't empty. It is a chaotic boiling soup of virtual particles. These are particles that pop into existence, borrow energy from the vacuum, exist for a split second, and then destroy each other. This is happening everywhere, all the time. It is happening inside your skull right now. This activity creates energy. And since Einstein taught us that energy is mass, this means nothing actually has a weight. So, physicists decided to calculate it. They took the equations of the standard model and added up all the energy of all the virtual particles jittering in the vacuum. They wanted to know the density of empty space. The number they got was catastrophic. The math says that the energy of the vacuum should be so intense, so heavy, that space-time should have curled up into a ball instantly after the Big Bang. The universe should have ripped itself apart or collapsed into a black hole in a fraction of a second. But look around you. The universe is still here. Space looks flat. It looks empty. It looks calm. When we measure the actual weight of the vacuum, which we call dark energy, we find a number that is incredibly small. So we have two numbers. The number the math predicts, and the number reality shows us. How big is the difference between them? It is 10 to the power of 120. That is a 1 followed by 120 zeros. This isn't just a mistake. This is the largest discrepancy in the history of science. It is called the vacuum catastrophe. Imagine you tried to estimate the weight of a grain of sand, and your math told you it weighed more than the entire observable universe. That is how wrong we are. This error tells us one of two things. Either our understanding of the universe is fundamentally broken, and we have no idea how gravity works, or the vacuum really is that heavy, and something else, some magical hidden number, is cancelling it out perfectly to within 120 decimal places. If the second option is true, it means we are balancing on a knife edge that is sharper than an atom. The forces trying to crush us are titanic, and the force saving us is a lucky accident. Why would the universe be balanced so perfectly on the brink of destruction? Why are we alive? If the Higgs mass is a trap, and the vacuum energy is a catastrophe, and the math says we should have been crushed billions of years ago, why are you sitting here? The most popular answer physicists give is called the anthropic principle. It goes like this. If the universe had collapsed, we wouldn't be here to ask the question. Since we are here to ask the question, the universe must be stable. Does that satisfy you? It shouldn't. It is circular logic. It is like winning the lottery 10,000 times in a row, and when the police ask you how you cheated, you say, well, if I hadn't won, I wouldn't be rich. It doesn't explain why you won. It just states the obvious. This logic implies something dark about our place in the cosmos. It implies that we are the victims of survivorship bias. If the math says that a stable universe is incredibly unlikely, a 1 in a trillion shot, then the only way to get a universe like ours is to roll the dice trillions of times. This suggests that our Big Bang was not a unique event. It implies a multiverse. Imagine an ocean full of bubbles. Each bubble is a universe trying to form. In the first bubble, the vacuum energy is too high. Pop. It collapses instantly. In the second bubble, the Higgs mass is too heavy. Pop. No atoms. In the third, gravity is too weak. Pop. No stars. This happens trillions upon trillions of times, an endless graveyard of dead, broken universes. And then, purely by accident, bubble number 7 trillion gets the numbers right. The vacuum energy cancels out. The Higgs lands on the ledge of 125. The stars ignite. That is where we live. We are not the chosen ones. We are just the statistical freak that didn't pop yet. We are walking through a field of corpses, thinking we are immortal because we haven't stepped on a mine. But the problem with statistical luck is that it runs out. We see signs that the luck is already fading. The dark energy that holds our vacuum open is not staying constant. The universe is accelerating. The expansion is getting faster. The balance is shifting. But if we are just a bubble floating in a much larger, darker ocean, what is happening outside our skin? If we are the lucky survivor, who are the neighbors? This brings us back to the anomaly we started with. Remember the W boson? The particle that was too heavy? That extra weight didn't come from nowhere. It came from an interaction. If our bubble is leaking, or if something is pushing against it, we should see the cracks. And it turns out, the biggest crack isn't in the vacuum energy. It is in gravity itself. Why is gravity so weak? And why does it seem to be leaving our universe entirely? If our universe is a bubble floating in a graveyard, and if the walls are cracking, we should see evidence of what is outside. And the clearest evidence isn't out in deep space. It is right there in your kitchen. Go to your refrigerator. Look at the little magnet holding up a photograph or a grocery list. That magnet is defying the entire planet. Think about the tug of war happening there. The magnet is pulling the photo up. The entire Earth, all 6 septillion kilograms of rock, iron, and magma, is pulling the photo down, and the magnet is winning. A tiny piece of metal the size of a coin is stronger than the gravity of an entire world. This doesn't make any sense. In physics, we expect the fundamental forces of nature to be roughly equal. The force that holds atoms together, electromagnetism, and the force that holds stars together, gravity, should be peers. They were born at the same moment in the Big Bang, but they are not peers. Gravity is the runt of the litter. If you do the math, gravity is not just a little bit weaker. It is 10 to the power of 36 times weaker than the electromagnetic force. That is a 1 with 36 zeros. It is the difference between a single grain of sand and the entire Sahara Desert. Why? Why is gravity so pathetic compared to the other forces? Why does it take the mass of an entire planet just to keep your feet on the ground, while a tiny static shock from a doorknob can hurt you? Physicists call this the hierarchy problem. It is a nice name for a complete failure of logic. If gravity is truly a fundamental force of our universe, it should be strong. The fact that it is a ghost suggests that we are looking at it wrong. Imagine you are in a room listening to a speaker. The sound is incredibly quiet. You turn the volume up to the max, but you can barely hear a whisper. You assume the speaker is broken. But what if the speaker isn't broken? What if the speaker is actually blasting at full volume, but it is located in the room next door? What if the gravity we feel isn't native to our space? What if it is leaking in from somewhere else? Or worse, what if it is generated here but it is leaking out? If gravity is escaping, where is it going? To find out where gravity is hiding, we have to stop thinking of the universe as a 3D box. We have to start thinking in string theory. This theory suggests that the fundamental particles of matter, electrons, quarks, photons, are not little dots. They are tiny, vibrating strings of energy. There are two types of strings. First, you have open strings. These look like a piece of thread. They have two loose ends. Then you have closed strings. These are loops, like a rubber band. They have no ends. This shape makes all the difference. String theory says our universe is like a sticky membrane, or a brain for short. Think of it like a sheet of flypaper floating in a much larger, empty space called the bulk. The matter that makes up your body, the electrons and protons, are open strings. Their loose ends are chemically stuck to the flypaper. That is why you are trapped in 3 dimensions. You physically cannot leave the sheet. Light is also an open string, so it is stuck too. That is why we can't see anything off the sheet. But gravity is different. The particle that carries gravity is called the graviton. And according to the math, the graviton is a closed string. It is a loop. It has no loose ends. It cannot get stuck to the flypaper. This means gravity is free to leave. It can drift off our brain and float out into the bulk, into the 4th or 5th dimension. This solves the riddle of the magnet. Gravity isn't weak. It is just diluted. It is generated here, but 99% of it instantly leaks out of our dimension and disappears into the higher reality next door. We only feel the tiny fraction that stays behind. So, we are living in a leaky room. We are bleeding energy into the void every second. But this isn't just a theory on a blackboard. CERN is actively trying to prove it. When they smash particles together at the Large Hadron Collider, they measure the energy before and after the crash. The law of conservation of energy says the numbers must match. Whatever you put in, you must get out. But they are looking for missing energy. They are looking for a collision where the energy after the crash is less than the energy before. If they find that, it means a graviton was created in the crash and immediately flew out of our dimension. It means we caught the thief leaving the scene. But if gravity can leave our world, does that mean gravity from other worlds can enter ours? If we are floating in a bulk full of other brains, and gravity is the only thing that could cross the gap, are we feeling the pull of something else? What if the invisible mass we call dark matter isn't a cloud of gas? What if it is the shadow of a neighbor? So, how do we catch a ghost leaving the room? How do we prove that gravity is actually leaking into a 4th dimension? We use the strictest law in physics, the law of conservation of energy. This law states that energy can never be created, and it can never be destroyed. It can only change shape. If you burn a log, the energy in the wood turns into heat and light. If you add up all the heat and all the light, it will equal exactly the energy that was in the log. You never lose a single penny. The universe is a closed bank vault, or at least it is supposed to be. At the Large Hadron Collider, they test this law millions of times a second. They smash 2 protons together at the speed of light. They know exactly how much energy goes into the crash. Then, they catch all the debris. They measure every photon, every quark, and every electron that flies out. They add up the total energy of the wreckage. Usually the numbers match perfectly. Input equals output. But they are looking for the specific collisions where the numbers don't match. They are hunting for missing transverse energy. Imagine you smash a piggy bank full of coins on the floor. You count the coins scattered on the carpet. You know there was $10 in the pig, but you can only find $9. You check under the sofa. You check your pockets. The room is sealed. The windows are locked. But $1 is gone. Absolute magical disappearance. In a closed universe, this is impossible. But in a brain world universe, the answer is simple. The coin didn't vanish. It just rolled off the paper. If CERN detects this missing energy, it will be the first physical proof that the wall of our reality has a hole in it. It means a graviton, a particle carrying that energy, escaped the collision and flew off our dimension into the bulk. This changes everything. It means we are not living in a vault. We are living in a sieve. And if we are a sieve, what are we losing? We are not just losing gravity. We are losing information. Every particle that leaves takes data with it. It takes a record of the collision, a piece of the history of our universe, and carries it out into the void where we can never retrieve it. We are slowly bleeding out. But this door swings both ways. If gravity can leak out of our universe to the layer above us, then gravity from the layer above can leak down to us. If there is a structure floating in the dark right next to our brain, we wouldn't be able to see it with our eyes. Light is stuck to our sheet, but we would feel its weight. Does that sound familiar? Invisible mass? Heavy gravity? No light? We have a name for that. For 80 years, astronomers have been staring at a problem called dark matter. They look at a galaxy, and they see it spinning too fast. The visible stars don't have enough gravity to hold it together. It should fly apart like a broken merry-go-round. But it stays solid. To explain this, we invented a ghost. We said, there must be a giant cloud of invisible matter inside the galaxy holding it together. We have spent billions of dollars trying to catch a particle of dark matter. We built detectors deep underground. We built space telescopes. We found nothing. Not one single particle. Why is it so hard to find? Maybe because it isn't there. String theory offers a much creepier explanation. It suggests that dark matter isn't a cloud of gas inside our galaxy. It is the shadow of a different galaxy. Picture our universe again as a thin sheet of paper floating in the air. Now, imagine another sheet of paper floating parallel to it, just a few millimeters away. You cannot see the other sheet. Light travels along the paper, not between them. To you, the space above the paper is empty. But on that other sheet, there is a star. A massive, heavy star. Gravity, because it is a closed loop, can jump the gap. The gravity from that star radiates out, crosses the few millimeters of bulk space, and hits our sheet. What do we experience? We see a spot in empty space that has intense gravity. Things orbit around it. Light bends around it. But there is nothing there. It is a poltergeist. This is the shadow brain hypothesis. It implies that we are not alone in the room. We are sharing the same volume of space with a parallel reality, separated by a dimensional gap smaller than an atom. They could have stars. They could have planets. They could have civilizations. We are haunting each other. Their gravity holds our galaxies together, and our gravity pulls on theirs. We are locked in a dance with a partner we can never touch. This turns the concept of aliens upside down. We are looking for life on distant planets, light years away. But the most advanced life might be sitting right here, right now, folded into a dimension that touches your skin, but is forever locked away by the geometry of the bulk. But if they are right there, is it safe? If two sheets of paper are floating that close to each other, what happens if they drift? What happens if the gap closes? And looking at the movement of our own galaxies, it seems like something massive is indeed reeling us in. We are not just drifting, we are flowing. If we are sharing our room with an invisible giant, is it just watching us, or is it doing something to us? To answer that, we have to look at how the universe moves. You have probably heard that the universe is expanding. Galaxies are supposed to be drifting away from each other like dots on a balloon that is being inflated. In this model, everything moves apart. There is no preferred direction. There is no north or south in space. It is just a smooth, uniform spread. But in 2008, a team led by Alexander Kashlinsky at NASA found a glitch in the expansion. They looked at the motion of huge galaxy clusters, groups of thousands of galaxies bound together by gravity. They expected to see them expanding randomly. Instead, they saw a river. They found that millions of galaxies, including our own Milky Way, are not just expanding. They are drifting. They are all moving in the same specific direction, towards a patch of sky between the constellations of Centaurus and Hydra. And they are moving fast. The speed is shocking. About 600 kilometers per second. That is 2 million miles per hour. Physicists call this the dark flow. Think about what that implies. It is like you are swimming in a calm, expanding ocean. You think you are just floating. But suddenly you realize that you, and every other swimmer for 1,000 miles, are being pulled by a silent, invisible current in one direction. You aren't swimming anymore. You are being dragged. The scariest part about this flow is the math of the pull. To drag that much mass, millions of galaxies, at that speed, you need a gravitational source of impossible size. If you took every star, every black hole, and every dust cloud in the known universe and piled them up, it still wouldn't be heavy enough to generate that kind of pull. So, what is pulling us? Kashlinski's team suggested that the source of the gravity lies outside the visible universe. It implies that the bubble of our observable reality is not isolated. Something beyond the edge of our map is reeling us in. We are being dragged by a monster that is too far away to see, but massive enough to tilt the entire cosmos on its side. We are flying blind into the mouth of the unknown. But thanks to radio telescopes that can punch through the dust, we have started to map the heavyweights waiting for us in the dark. Is it a supercluster of galaxies, or is it something much stranger? We tried to find the monster. We pointed our telescopes at the destination of the flow. First we found the Great Attractor. It is a gravitational anomaly about 250 million light years away. It is pulling our galaxy and thousands of others towards it. For years we thought this was the answer. We thought this was the end of the river. But when we finally got a better look, the math didn't hold up. The Great Attractor is big, but it isn't big enough. It accounts for maybe 40% of the speed. It is just a crumb on the trail. So we looked behind it. Deep in the background, we found the Shapley supercluster. This is the single largest concentration of galaxies in the nearby universe. It is a titan. It contains the mass of 10,000 Milky Ways. It is a city of stars so heavy, it warps space-time like a bowling ball on a trampoline. But here is the horror story. Even the Shapley supercluster isn't big enough. The math says that even its massive gravity accounts for only a fraction of the dark flow. The real source, the true Leviathan, is still further out, past the horizon, hidden in the unobservable universe where light has not had time to reach us yet. Physicists call this the tilt theory. They suggest that our entire observable universe is just a small patch on a slope, and we are sliding downhill. We are falling into a gravitational drain created by a structure so colossal that our entire reality is just a speck of dust orbiting it. We will never see it. The light from it will never reach us because the space between us is expanding too fast. We are like ants on a leaf, flowing down a river, unaware that a waterfall is coming. We just know that the current is getting faster. But if we're sliding downhill, and if the shadow brain theory is correct, what happens when we hit the bottom? What happens when two universes, driven by this impossible gravity, finally slam into each other? It turns out we might have already survived one of these crashes. And the evidence isn't a theory. It is a scar that is printed on the sky above your head right now. If we are sliding toward a monster, and if we are haunted by a shadow universe next door, how does this story end? Or more importantly, how did it begin? The standard story of the Big Bang says that the universe exploded out of nothing. One moment there was void. The next moment there was fire. It sounds like a miracle, but a theory called the ekpyrotic universe, proposed by physicists Paul Steinhardt and Neil Turok, suggests that the Big Bang wasn't a birth. It was a collision. Remember the two sheets of paper? our brain and the shadow brain. According to this model, these sheets are not fixed in place. They move, they ripple as they float through the bulk, and because gravity pulls them together, they are destined to meet. Imagine two giant metal symbols slamming together in a dark room. The moment of impact is catastrophic. All the kinetic energy of the moving brains is instantly converted into heat and radiation. To an observer inside the sheet, it looks like the entire universe suddenly caught fire. The temperature spikes to trillions of degrees, matter is vaporized and reformed. Space expands rapidly from the shockwave. We look at that event and call it the Big Bang. But it wasn't a beginning. It was just a clap of thunder. This implies that our universe is not a one-time event. It is a cyclic engine. The brains crash. The energy creates a hot, young universe. The brains bounce off each other and drift apart. The universe cools down. Galaxies form. Life evolves. We live our lives in the quiet period as the plates move away. But gravity is relentless. It eventually slows down the drift and pulls the plates back together. It means we are trapped in an eternal loop of destruction and rebirth. Bang. Expansion. Cooling. Attraction. Crash. Bang. And the horror is that we don't know where we are in the cycle. We know the plates are moving. We know the dark flow is pulling us. But since we can't see the bulk, we can't see the other plate coming. The sky could be falling right now. The next collision could happen in 1 billion years, or it could happen tomorrow. We are living on a ceiling that is destined to collapse. But is this just a mathematical nightmare? Is it just a scary story physicists tell each other? Usually theories about before the Big Bang are impossible to prove, because the fire of the explosion destroys all the evidence. You can't find fingerprints in an inferno. But what if the crash left a dent? What if we could look at the oldest light in the universe and find a scar that proves we hit something? To find the scar, we have to look at the cosmic microwave background, or CMB. This is the afterglow of the Big Bang. It is a map of the oldest light in existence. According to the standard model, this map should look like static noise, random speckles of hot and cold, distributed evenly like sand on a beach. The universe should be uniform. But in 2013, the Planck satellite gave us the most detailed map ever made. And when astronomers looked at the southern hemisphere of the sky, they saw something that made them check their instruments for dirt. They saw a massive, deep blue hole. It is called the CMB cold spot. It is a region of space about 1 billion light years across that is significantly colder than everything around it. It shouldn't be there. Statistically, the chance of a spot that big appearing by random luck is almost zero. It is like looking at a calm ocean and seeing a giant frozen whirlpool that refuses to move. Scientists tried to explain it away. They said it was a supervoid, just a big empty space with fewer galaxies. But when they counted the galaxies in that direction, the void wasn't empty enough to explain the temperature drop. The math didn't add up. So what is it? Physicist Laura Massini-Houghton calculated that this spot is exactly what it would look like if our universe had collided with another universe in the distant past. Imagine two soap bubbles bumping into each other. The point of contact leaves a dent. If that is true, the cold spot is the first physical evidence that the ekpyrotic model is real. It is a bruise on the skin of our reality. It proves that we are not alone in the multiverse. We have a neighbor. And billions of years ago, we crashed into them. We survived the last crash. But the existence of the bruise implies that the membrane we live on is soft. It is malleable. It can be bent, dented, and broken. And this leads us to a question that dismantles the very idea of space itself. If our universe is just a thin membrane that can be bruised, and if gravity can leak out of it, and if it has a 2D surface, why do we think it has depth? Why do you feel like you're occupying a 3D volume, when all the physics points to the fact that you might be living on a flat surface? We are about to enter the deepest rabbit hole of all. We are going to look at why your body might be a hologram. To understand why the three-dimensional world around you might be a lie, we have to talk about trash. Specifically, what happens when you destroy something. If you take a book, say the complete works of Shakespeare, and throw it into a fire, you assume the information in that book is gone. The pages turn to ash. The ink turns to smoke. The story is lost. But in physics, that is not true. There is a fundamental rule called unitarity. It states that information is never lost. The universe is a strict accountant. Every distinct state of matter must have a distinct past and a distinct future. If you were smart enough, and if you had a powerful enough computer, you could theoretically collect every molecule of ash, every photon of light, and every wisp of smoke from that fire. You could reverse the laws of physics and reconstruct the book perfectly. The story is still there. It is just scrambled. This rule is the bedrock of science. It means that the past is real. It means that cause leads to effect. But in 1976, Stephen Hawking found the one place where this rule goes to die: black holes. Hawking realized that black holes are not perfectly black. They leak. They radiate energy, now called Hawking radiation, and slowly evaporate over trillions of years. Eventually, the black hole disappears completely. It pops out of existence. But here is the problem. The radiation that leaks out is random. It is just thermal noise. It contains no data about what the black hole ate. So if you throw that Shakespeare book into a black hole and wait for the hole to evaporate, the book is gone. The radiation doesn't carry the text. The hole is gone. The information is deleted from the universe. This sounds like a technicality, but it is a catastrophe. If information can be destroyed, then we cannot calculate the past from the present. It means the movie of the universe can't be rewound. It breaks the link between cause and effect. And if you break cause and effect, you break physics. Suddenly, the foundation of reality, the idea that the past determines the future, dissolves. If a black hole can delete a book, what stops the universe from deleting history? This discovery terrified physicists. It implied that our reality is leaky. It implies that the hard drive of the universe has a delete button that shouldn't exist. So either Hawking was wrong, and black holes are not what we think they are, or quantum mechanics is wrong, and information is not immortal. Which one is it? This paradox triggered a 40-year civil war in the physics community. It was called the Black Hole War. On one side, you had Stephen Hawking. He doubled down. He said, "The information is gone. The laws of physics change inside a black hole. Deal with it." On the other side, you had Leonard Susskind and Gerard 't Hooft. They realized the stakes. They argued that if information is lost, energy conservation fails, and the temperature of the universe becomes undefined. Basically, if Hawking is right, reality doesn't make sense. They needed a solution that saved the book without breaking the black hole. They needed to find a way to keep the information safe, even if the object falls into the pit. And the solution they found is so radical that it changes the definition of place entirely. They asked a simple question. When the book falls into the hole, where is it? We usually assume it goes inside. We assume it occupies the three-dimensional volume behind the event horizon. That is common sense. A shoe in a box is inside the volume of the box. But Susskind realized that looking at the volume was the mistake. What if the information never actually goes inside? What if, when the book hits the horizon, the point of no return, it gets scrambled and plastered onto the surface of the hole? Imagine a can of soup. The soup is the three-dimensional stuff inside, but the label is a two-dimensional sheet wrapped around the outside. The label tells you exactly what is in the soup. It contains all the data: tomato, salt, 500 calories. Susskind proposed that a black hole is exactly like that can. The real book, the data, the text, the meaning, is encoded on the 2D surface of the event horizon. The 3D version that falls inside is just a projection. It is a hologram. This saves physics. The information isn't destroyed, it is just reformatted. It turns from a 3D object into a 2D code. The radiation can then read the code on the surface and carry it back out into the universe. But do you see the trap this sets for us? If all the information required to describe a massive 3-dimensional star can be stored on a flat 2-dimensional surface, then the 3rd dimension is technically unnecessary. It is redundant. The volume, the inside of the hole, is just a reflected image of the data on the shell. And if a black hole is a hologram, and a black hole is just extreme gravity, what prevents the rest of the universe from being a hologram too? Are we also just data painted on a wall? If a black hole is a hologram, we have to ask, what is the universe? Because mathematically, our universe looks suspiciously like the inside of a black hole. We are trapped in a bubble of gravity. We have a maximum speed limit. And most importantly, we have an edge. Look out into the night sky. If you look far enough, you hit a wall called the cosmological horizon. It is about 46 billion light years away. We cannot see past it, and nothing can reach us from the other side. It is the shell of our reality. The holographic principle suggests that this shell is acting exactly like the surface of the black hole. It implies that all the information describing the universe, every star, every planet, and every atom in your body is physically stored on that distant 2D boundary. Think about what that means for you. You feel like you are sitting in a room. You feel like you have depth. You can move forward and backward. But if this principle is right, the real you is not in the chair. The real you is a chaotic smear of data encoded on the furthest edge of the cosmos. You are a flat, 2-dimensional code. What you experience as walking through a room is just a projection. It is a hologram being beamed inward from the horizon. The lasers are the laws of physics, and the image they create is the 3D world. This sounds impossible. It sounds like a bad sci-fi plot. How can a flat surface create the perfect illusion of a solid world? To believe this, we would need a mathematical proof that a 2D world and a 3D world are actually the same thing. And in 1997, a physicist named Juan Maldacena gave us exactly that. Maldacena's discovery is called the ADS-CFT correspondence. It is a tongue twister, but the meaning is simple. He looked at two completely different mathematical worlds. The first world was a 5-dimensional universe with gravity, anti-de Sitter space. It had volume, it had depth. The second world was a 4-dimensional flat border without gravity, conformal field theory. It was just a shell. These two worlds shouldn't have anything in common. But Maldacena found a dictionary that translated one into the other perfectly. He proved that anything happening in the solid, deep world could be described perfectly by equations on the flat, empty shell. Every object in the bulk had a corresponding shadow on the boundary. This means that the third dimension is not a fundamental part of reality. It is a side effect. It is a user interface. Just like a video game screen is flat, but it convinces you that you are walking down a hallway. But if we are living in a digital projection, shouldn't we be able to see the pixels? If you zoom in on a photo, eventually you see the dots. If you zoom in on reality, do you hit a limit? We used to think space was smooth. We thought you could divide a meter into a centimeter, a millimeter, and so on forever. But we were wrong. There is a pixel size to the universe. It is called the Planck length. It is incredibly small, 10 to the power of a negative 35 meters. But it is not zero. You cannot have a position more precise than this. You cannot have a distance shorter than this. Physics stops working if you try to go smaller. This is the Bekenstein bound. It tells us that a region of space can only hold a finite amount of information. And crucially, that amount depends on the surface area, not the volume. This is the smoking gun of a hologram. The resolution of our world is limited by the size of the screen wrapping around it. We are pixelated. We are projected. But what holds the pixels together? If space isn't real, what stitches the image into a seamless whole? The answer seems to be the spooky connection Einstein hated the most. If our reality is pixelated, and if the solid world is just a projection from the edge of the universe, we are left with a massive engineering problem. What holds the pixels together? Why doesn't the image fall apart? If space is made of discrete chunks like Lego bricks, what is the glue that connects chunk A to chunk B? The answer brings us back to the phenomenon that Albert Einstein hated the most. He called it spooky action at a distance. We call it quantum entanglement. You probably know the basics. If you take two particles and entangle them, they become linked. If you spin one particle, the other spins instantly, even if it is on the other side of the galaxy. It happens faster than light. It breaks all the rules of separation. For a century, we thought this was just a weird magic trick that particles did inside space. But a new theory, proposed by Leonard Susskind and Juan Maldacena, flips the script. It is called ER equals EPR. It suggests that entanglement isn't happening in space. Entanglement is space. The theory argues that every time two particles become entangled, they create a microscopic thread between them. This thread is actually a tiny wormhole, an Einstein-Rosen bridge, tunneling through the geometry of reality. It stitches them together. Now, scale that up. Imagine that the empty void between the Earth and the Moon isn't empty. Imagine it is packed with trillions upon trillions of these tiny quantum threads, connecting every atom in the vacuum to every other atom. This dense network of connections is what creates the sensation of distance and geometry. You're not walking through empty air. You're walking through a web. Space-time is a fabric that is being knitted together, moment by moment, by the entanglement of quantum information. This explains gravity in a totally new way. Gravity isn't a force pulling you down. Gravity is the tension in the web. When you have a massive object like the Earth, it entangles with more particles. It creates more threads. The web gets tighter. The fabric curves because the stitching is denser. You feel that tension as weight. But this leads to a terrifying conclusion about the stability of the stage we are standing on. If space is generated by entanglement, what happens if you break the link? If you somehow manage to unentangle the particles in this room, the walls wouldn't just fly apart. The space between the walls would cease to exist. The concept of distance would vanish. The reality would dissolve into a non-geometric chaos of abstract data. We are literally held together by the spooky action of ghosts. We are a quilt stitched over a void. And just like a sweater, if you pull on the wrong thread, the whole thing can unravel. The universe relies on these connections to maintain the illusion of continuity. But as we saw with the false vacuum, the universe doesn't mind breaking its own rules. We have stripped away the walls, we have cracked the floor, and now we have dissolved the air itself. We have turned the physical world into a fragile, pixelated, leaky hologram. Is there anything left to hold on to? Let's stop for a second and look at the wreckage. We have been sitting here for an hour, and we have systematically dismantled every safety net you thought you had. We started with the ground beneath your feet. We found that the W boson is too heavy, and the Higgs field is too light, which means the vacuum of space is a trapdoor waiting to open. We found that we are not living in a stable valley, but on a crumbling ledge that could collapse at light speed before you finish this sentence. Then, we looked at the walls. We found that gravity is leaking out of our dimension, which implies that our universe is a leaky membrane floating in a much larger, darker bulk. We found that we are being dragged by a dark flow toward a monster we cannot see, and that we might have already crashed into another universe in the past, leaving a bruise on the sky. Then, we looked at the air itself. We found that the 3D volume you occupy is a lie. We found that black holes delete the interior and store data on the surface, and that our entire cosmos is likely a hologram projected from the horizon. We found that space is pixelated and stitched together by wormholes. It feels like we have hit rock bottom. It feels like there is nothing left to deconstruct. You might be thinking, okay, the physical world is a fragile illusion, but at least I am real. At least I have control over my own timeline. At least the future hasn't happened yet. This is the last refuge. We cling to the idea of time. We believe that even if space is fake, the story we are telling is real. We believe that the past is locked, the present is happening, and the future is a blank page waiting for us to write it. We believe we have agency. We believe we are the authors of our fate. But physics has one final, cruel card to play, and it is the card that takes away your freedom. We have to talk about the arrow of time. We have to talk about why you remember yesterday but not tomorrow. Is that a rule of nature? Or is it just a limitation of your brain? Because when we look at the experiments coming out of quantum labs right now, we see particles that don't care about your timeline. We see events in the future reaching back to change the past. We see a universe where the script is already written, the film is already in the can, and you are just a character reciting lines that were decided 13 billion years ago. If space is a hologram, time is a prison. And we have the experiment that proves the bars are real. It is called the quantum eraser, and it is going to break the last thing you trust, your own ability to choose. To understand why the future might be a prison, we have to look at the most famous experiment in the history of physics. It is called the double slit experiment. You have probably heard of it, but I want you to stop thinking about it as a science experiment and start thinking about it as a glitch in a video game, because that is what it is. Here is the setup. You have a wall with two vertical slits cut into it. Behind that wall, you have a detector screen. You take a gun that fires subatomic particles, electrons or photons, and you shoot them at the wall. Common sense tells you what should happen. The particles are like tiny tennis balls. Some will hit the wall and bounce off. Some will go through the left slit. Some will go through the right slit. On the back screen, you should see two vertical bands of impact marks. That is how matter works. That is how the world works. But when physicists actually run this test, that is not what happens. If they fire the particles and don't look at which slit they go through, the particles don't act like tennis balls. They act like water. They go through both slits at the same time. They interfere with themselves. On the back screen, you don't get two bands. You get an interference pattern, a complex series of many bands. This proves the particle is a wave. It is in two places at once. But here is where the glitch happens. The physicists say, okay, that's weird. Let's put a camera next to the slits to see which one it actually goes through. They turn the camera on. They fire the gun again. And suddenly, the particles stop acting like waves. They snap back into reality. They act like solid tennis balls. You get two bands on the screen. The interference pattern vanishes. Why? The only thing that changed was the information. The moment the universe knew that you knew which path the particle took, it rendered the particle as a solid object. If you don't look, it is a wave of probability. If you do look, it is a definitive chunk of matter. This is usually where the physics lesson ends. They tell you, observation collapses the wave function. But they miss the most disturbing question. How fast does the particle know? Does it know you are going to look before it hits the wall? To answer that, physicists decided to trick the universe. They designed a new version of the experiment. They wanted to see if they could fool the particle by deciding to look after it had already made its choice. They wanted to know if the logic of the universe works forwards or backwards. And in 1999, a team led by Yoon Ho Kim performed the delayed choice quantum eraser experiment. The results of that test shouldn't be possible. They violate the basic rule that cause must come before effect. They imply that the events of tomorrow are already shaping the events of today. The setup of the quantum eraser is complicated, but the logic is brutally simple. It is a trap for time. Here is what they did. They fired a photon at the double slits. The photon passed through the slits and hit the detector screen. The journey was over. The impact was recorded. The photon was dead. A dot appeared on the wall. But while that was happening, the scientists split the information about the photon's path and sent it on a longer journey. This information, the answer to which slit did it go through, traveled through a maze of mirrors and prisms. Crucially, the second journey took longer than the first one. This created a time gap. The photon hits the screen at time A. The information reaches the end of the maze at time B. At the end of the maze, the scientists had a choice. They could either look at the information, keep it, or they could scramble it, erase it. And here is the horror. They made this choice after the photon had already hit the screen. The photon was already dead. Its mark was already on the wall. History was written. Logic dictates that nothing the scientists do at time B can change what happened at time A. You cannot unscramble an egg. You cannot unbreak a glass. But the data showed the impossible. If the scientists decided to erase the information at time B, the record on the screen at time A showed an interference pattern, wave. If the scientists decided to keep the information at time B, the record on the screen at time A showed a clump pattern, particle. Do you see what that means? The photon hit the screen as a wave because the scientists were going to erase the data in the future. Or the photon hit the screen as a particle because the scientists were going to look at the data in the future. The particle knew what the choice would be before the choice was made. The future event caused the past event. This is called retrocausality. It destroys the idea of a linear timeline. We usually think of time as an arrow flying from the past to the future. But this experiment suggests that the arrow flies in both directions. The future is not a blank void. It is a solid reality that is pushing back against us. The year 3000 is just as real as the year 2000, and the events happening there are sending ripples back upstream to us right now. But if the future can rewrite the past, what does that say about your life? You think you're making free choices. You decide to click a video. You decide to drink coffee. You feel like the author of your own story. But if the end of the story is already written, and if the ending dictates the beginning, then you aren't writing anything. You are just fulfilling a requirement. You are a puppet dancing on strings that stretch backward from the end of time. And if we look at the math of electromagnetism, we can actually see the strings. So, we have a photon that changes its behavior in the past because of a decision made in the future. This breaks every rule of logic we have. How can a particle know what hasn't happened yet? The standard answer from uncomfortable physicists is to say, it's complicated. They talk about causal correlations. They try to soften the blow. But if you look at the raw data, the implication is much sharper. It implies that the timeline is not a straight arrow where A leads to B. It implies that A and B are talking to each other across the gap. Think about what needs to happen for the quantum eraser to work. The photon at the slit, time A, needs information from the detector setting, time B. That information has to travel backwards against the flow of time to reach the particle before it hits the screen. This sounds like magic. It sounds like time travel. But in the mathematics of the universe, time travel for a particle is not actually forbidden. In fact, it might be the default setting. We are so used to the idea that time flows forward that we assume the laws of physics enforce that direction. We assume that there is a fundamental equation somewhere that says t must increase. But if you actually open the textbooks and look at the fundamental laws, the ones that govern gravity, electromagnetism, and quantum mechanics, you find a shocking omission. The arrow of time isn't there. The equations don't care. And this symmetry suggests that our perception of past and future is just a biological illusion, while the underlying reality is a two-way street. To see this symmetry, imagine recording a video of two billiard balls colliding on a pool table. You watch the video. Ball A hits ball B, and they bounce off each other at specific angles. Now, play the video backward. You see the balls moving in reverse, colliding, and separating. Here is the question. Does the backward video break any laws of physics? No. The angles are correct. The transfer of momentum is correct. If you showed that video to a physicist, they wouldn't be able to tell you if it was running forward or backward. The math works perfectly in both directions. This is called time reversal symmetry. It applies to Newton's laws. It applies to Schrödinger's equation for quantum particles. It applies to Maxwell's equations for light. To an atom, past and future are just directions, like left and right. An electron doesn't feel time passing. It just occupies a coordinate. So why do we feel time? Why can you remember the past, but not the future? The answer is usually entropy. Systems tend to get messier. A glass breaks, but it never unbreaks. But entropy is a statistical rule for large groups of atoms. It explains the flow of heat. It doesn't explain the behavior of the individual particles that make up the glass. At the fundamental level, the level of the stuff you are made of, the future is just as accessible as the past. And if the equations allow waves to travel backward in time, why don't we see them? Why don't we see light coming out of our eyes before we turn on the lamp? The terrifying answer proposed by two legends of physics is, we do. We just don't recognize it. In the 1940s, John Wheeler and Richard Feynman looked at the math of the electron. They noticed a ghost in the machine. When an electron shakes, it emits a photon. The equation for this emission produces two distinct solutions. One wave travels forward in time. This is called the retarded wave. It is the light we see. But the math also insists on a second wave that travels backward in time. This is called the advanced wave. Most physicists just crossed out the backward wave. They said, that makes no sense, let's pretend it's zero. But Wheeler and Feynman asked, what if we take the math seriously? They developed the absorber theory. It argues that every interaction in the universe is a handshake across time. When you look at a star, the electron in the star sends a retarded wave forward to your eye. But at the exact moment your eye receives it, the electron in your retina sends an advanced wave backward through time to the star. The present moment, the reality you're experiencing right now, is simply the interference pattern where these two waves crash into each other. The future causes the past just as much as the past causes the future. This implies that the future isn't a void waiting to be filled. It is a solid continent that is already there, broadcasting signals back to us. The year 3000 exists. It is emitting waves right now. Those waves are hitting us, influencing our particles, and shaping the events of today. We call it randomness or chance, but it might actually be the pressure of tomorrow pushing us into position. And if the future is already solid enough to send signals, that leads to the most claustrophobic concept in all of physics. It turns the universe into a block of ice. This concept is the direct consequence of Einstein's theory of relativity. Before Einstein, we thought time was a universal clock ticking at the same rate for everyone. Now was the same for you and for a guy on Mars. But Einstein proved that time is relative. Speed and gravity change the flow of the clock. This destroyed the idea of simultaneity. Two events can happen at the same time for you, but at different times for someone moving past you. If now is subjective, then you cannot draw a sharp line between the past and the future. Einstein realized that the only way to make the math work was to treat time as a fourth dimension of space. You have length, width, height, and duration. If you look at the universe from outside, from a God's eye view, you don't see a movie playing. You see a static, four-dimensional object. Physicists call it the block universe. Imagine a loaf of bread. The entire loaf exists at once. Each slice of the bread is a moment in time. We are like 2D creatures living inside one slice, moving to the next slice, thinking that the previous slice has disappeared, and the next slice hasn't been baked yet, but the loaf is already baked. The dinosaurs are still alive in their slice. Your birth is still happening in its slice, and your death exists in a slice a few inches down the loaf. It is already there. It is frozen in the crystal of space-time. This means that becoming is an illusion. Nothing ever truly changes. The entire history of the cosmos is a single, static, geometric structure. We are just consciousness crawling along a pre-carved groove in the block. And if the groove is pre-carved, what does that mean for your ability to steer? If the future is as solid as the past, does choice exist? Or are we just watching a first-person movie that was filmed 13 billion years ago? This brings us to the nightmare of superdeterminism. It is the trapdoor that closes the argument about free will. We want to believe that quantum mechanics saves us. We like the idea that particles are random, because randomness leaves room for freedom. If the future isn't set, we can change it. But there is a loophole in the math called Bell's theorem. John Bell designed a test to prove that particles don't have hidden secrets. He proved that local realism is false. Either particles communicate faster than light, or they don't have defined properties until we look. But Bell made one assumption in his test. He assumed statistical independence. He assumed that the scientist is free to choose the settings on the detector. He assumed that the atoms in the physicist's brain are not conspiring with the atoms in the particle. Superdeterminism asks, what if they are conspiring? What if the Big Bang set up the initial conditions of the universe so precisely that every random choice you make is actually pre-correlated with the result you're gonna get? Imagine a magician who asks you to pick a card. You think you have a free choice, but the magician arranged the deck, the lighting, and your angle of vision so that you had to pick the ace of spades. You felt free, but the outcome was forced. Superdeterminism suggests the universe is that magician. It implies that there is no randomness. The reason we see weird quantum patterns is that the universe is plotting against us. The atoms in your brain that decide to measure spin-up were correlated with the atoms in the electron that decided to be spin-up 13 billion years ago. If this is true, then you are not an agent. You are not a player. You are a puppet. The strings are invisible, woven out of the initial conditions of the Big Bang, but they are pulling you right now. You didn't choose to watch this video. The causal chain that led to this moment was forged before the Earth cooled. The script is finished. We are just reciting the lines. But if the script is finished, and the universe is a block, who wrote the code? And if the code is this precise, surely it implies an architect? If the universe is a rigged script, what language is the script written in? We assume the universe is made of stuff. We think there is a hard physical reality at the bottom. Rocks, atoms, energy. We think mathematics is just a tool we invented to describe the stuff. It is like a language. The word apple describes the fruit, but the word is not the fruit. But the deeper we look, the more this distinction disappears. In the 1960s, the physicist Eugene Wigner pointed out something spooky. He called it the unreasonable effectiveness of mathematics. He asked, why does the physical world obey complex abstract equations so perfectly? Why does a planet billions of miles away move exactly according to a formula you scribbled on a piece of paper? Max Tegmark, a cosmologist at MIT, suggests a radical answer. He argues that math isn't describing the universe. The universe is math. Look at an electron. What is it made of? If you zoom in, you don't find a tiny billiard ball. You find a list of numbers. Mass, 9.1. Charge, -1. Spin, 1/2. That is it. If you take away the numbers, there is nothing left. The stuff is just a placeholder for the data. Tegmark calls this the mathematical universe hypothesis. It implies that our reality is exactly like a video game. When you play a game, you see a tree. It looks solid. It casts a shadow. But if you open the game file, there is no tree inside. There are only lines of code. The solidity is an illusion created by the processing of the numbers. If this is true, it means we are characters living inside a giant, complex equation. We are data structures processing other data structures. But usually, this is just a philosophical idea. It is a nice thought experiment. Until recently, we didn't have any physical proof that the universe was running on code, but then a physicist named S. James Gates looked deep into the equations of supergravity, and he found something that shouldn't be there. He found a browser history. S. James Gates is a legend in the field of supersymmetry. He wasn't looking for a simulation. He was just trying to solve the math of how gravity behaves at the quantum level. He was analyzing a specific set of equations related to quarks and leptons. To visualize the math, he turned the equations into graphs, geometric shapes made of dots and lines. He calls them adinkras. As he studied these shapes, he noticed a pattern. The arrangement of the lines looked familiar. It wasn't random physics. It was a specific, recognizable logic structure. He realized he was looking at computer code. Specifically, he found a string of doubly even self-dual, linear binary error-correcting block codes. That is a mouthful, but you use this code every day. It is the exact same class of algorithms that we use in Ethernet cables and Wi-Fi signals. Why would the fundamental equations of the universe contain code for Wi-Fi? This discovery is like looking at the DNA of a biological cell and finding a line of text that says, "Copyright Microsoft 1998. It is a signature. It suggests that the laws of physics are not natural. They are engineered. If the universe were purely analog, just a blob of energy expanding forever, there would be no need for discrete digital codes buried in the math. Analog systems don't use binary, but if the universe is digital, then finding binary code in the basement makes perfect sense. It means we have found the machine language of the simulation. But the specific type of code Gates found is even more disturbing. It isn't just data storage, it is error correction. Why does the universe need to correct errors? What is it trying to fix? To understand why error correction is a smoking gun, you have to talk to a computer engineer. In the 1940s, Claude Shannon, the father of information theory, figured out how to send a message through a noisy channel without losing data. If you send a stream of zeros and ones through a bad wire, static will flip some of the zeros to ones. The message gets corrupted. Shannon's solution was to add extra bits of code, redundant data that allow the receiver to check the math and fix the broken bits automatically. This is what allows you to watch Netflix without the video crashing every second. Your browser is constantly correcting the errors in the stream. So, why does the fabric of space-time contain the same algorithm? If the universe is a physical object, it doesn't make mistakes. A rock is just a rock. It doesn't need a spell checker. But if the universe is a simulation or a transmission of data, then it is vulnerable to noise. Bits can flip. Data can rot. Without an error correction mechanism, the simulation would crash. The laws of physics would drift. Gravity would stop working on Tuesdays. The fact that we found this code in the equations of supergravity suggests that our reality is being actively stabilized. It implies that there is a system running in the background, checking the integrity of the atoms in your body, making sure they don't dissolve into noise. We are living in a patched version of reality. But if there is a code, and if there is a patch, there must be a computer. And if there is a computer, there must be an architect. This brings us to the logic trap that convinced Elon Musk and Neil deGrasse Tyson that we are almost certainly not real. It is called the simulation trilemma. In 2003, the philosopher Nick Bostrom published a paper that destroyed the idea of reality using simple statistics. He proposed three possibilities for the future of any civilization.
In the standard
Option
model
1.
of cosmology,
Every
the
civilization
universe
goes
should be
extinct
roughly uniform.
before they
When you
figure
zoom
out how to
far
build a
enough.
computer
Sure,
powerful enough
galaxies
to
cluster
simulate a
together
universe.
and leave empty
They blow
spaces
themselves up with
between them.
nukes or biology.
That is expected.
Option 2.
But a region
They
this
reach the
enormous
technology,
with such a
but they lose
significant
interest.
deficit of matter
They decide simulating
that pushes
history
the
is boring
boundaries of
or
what
unethical,
random chance
so they
can
never
explain.
turn the machines on.
Computer
Option
simulations
3.
of how
They
the
survive,
universe evolved
and they
from the
run
Big Bang
simulations.
rarely produce
If option
voids
3 is true,
this large
they won't
and
just
this
run
empty.
one
When
simulation.
they do,
They will run
it
billions.
requires exceptionally
They will simulate
rare
the
initial
past.
conditions.
They will
The
simulate
statistical
alternative
probability
histories.
is less
They
than
will
1
simulate
in
worlds where
1,000.
Germany won the war,
Some
or where
scientists
dinosaurs didn't
calculated
die.
it would take a
This
10
means there will be
sigma
one
deviation
base
from average
reality
density,
and billions of
meaning
simulated
it is
realities.
So unlikely that
Now,
you might
look
not
at the
find
odds.
one in the
If there are
entire
billions of fake
observable
worlds
universe.
and only one
Yet
real
here we are,
world, and they look
living inside
exactly
one.
the same from the
The
inside,
implications began
what is the chance that
cascading
you are in the real one?
If we reside,
The math
depending
says
on
the
whether
chance
they
is
look at
1
the
in a
ancient
billion.
universe
It is
or the
effectively
nearby
0.
universe.
If you believe that
The
humanity
numbers
will survive the
disagree
next
by
1,000 years,
9%,
and if you
which
believe
sounds
we will
small,
keep playing video
but
games,
represents a crisis.
then you logically must
Both
accept that you are in a game right
are
now.
incredibly precise.
You are an NPC.
Both should give
The memories
same
you have
answer.
of your
They
childhood
do not.
are just
If
backstory
Earth
files
sits
uploaded to your
inside a
character
massive
model
underdense
to give you
region,
motivation.
Gravity from
The
the
room you
denser
are sitting
matter
in is a
surrounding
render.
the void
This
would
feels
pull
insulting.
outward on galaxies
You feel
within
real.
it. That
You
would
feel
add
pain.
extra velocity
You feel
to
love.
their motion away from
A computer
us,
program shouldn't
making
feel this
the local
vivid.
expansion
But look
appear
at the
faster
trajectory
than
of our own
average.
tech.
Suddenly,
40 years
the
ago,
conflicting
we had
measurements
Pong,
made sense.
2
We are
rectangles
not
and a
measuring
dot.
the universe incorrectly.
Today, we have
We are measuring it
photorealistic
from
VR.
inside a hole.
In another
This
40 years,
realization
we will have
changed
direct brain
everything,
interfaces.
But it also raised
We are
an
already
uncomfortable
building the
question
Matrix.
that
Why do you
cosmologists
think we are the
still
first
grappling
ones to
with.
do it?
If our
And if you look
location is
closely
this
at the
unusual,
physics of our world,
can we trust
you start to see
anything
the
we think we know
limitations of
about
the hardware we are
cosmos?
running on.
What comes
We have
next
found the speed
reveals
limit of the
just how
processor.
strange our cosmic
Ask yourself a
neighborhood
simple
really
question.
is. Cosmic
Why
voids
is there
are
a speed
not
limit?
truly empty.
Why
which
can
makes
light
them
only
even
travel at roughly
stranger than
300
their name
million meters per
suggests.
second?
Between these
Why
lonely
not faster?
galaxies stretches
Why not
space
instant?
that contains mainly dark
Why not
matter,
faster?
dark energy,
Why not
and
instant?
occasional wisps of
In a
hydrogen
purely
gas.
physical
The
universe,
density
infinite
is so
speed
low
should be
that
possible.
gravity barely
If you push
functions.
something hard enough,
Without
it should go
enough mass
faster.
to pull things
But in
together,
our universe,
structure
there is a hard
formation
ceiling.
essentially stops.
No matter how much energy
No
you
new
add,
galaxy
you
clusters
cannot
form.
break that number.
No rich
In computer
superclusters
science,
emerge.
we have a
The
different name
void
for this.
stays
We call it
a void.
latency.
This emptiness
Every processor has a clock
consequences
speed.
that ripple
It can
through
only
physics
calculate a
itself.
certain number of
Gravity
operations per
is
second.
already the weakest
Information
fundamental
cannot
force
move
of
across the
nature,
motherboard instantly.
requiring enormous
It takes
masses
time to travel
like
from the
planets
memory to the
and
CPU.
stars to show
If you were
noticeable
building a
effects.
massive simulation
In
of a
a void
universe,
where mass is
you would have to put a
scarce,
cap on the
gravity
speed of
becomes
information.
even less relevant.
If things moved instantly,
The dominant
the
force
computer would
becomes
have to
dark
calculate
energy,
every interaction in the
mysterious
entire
pressure that
cosmos
accelerates
simultaneously.
cosmic expansion.
It would
In
crash the
dense
server.
regions full of
By
galaxies,
limiting the speed of light,
gravity fights
the architect
against
buys
dark
time.
energy, slowing
It ensures
down the
that
expansion
causality
in those
happens in a
areas.
manageable
Inside
sequence.
voids,
It prevents the
gravity
system from
loses that tug
overloading.
of war.
This
Dark
explains
energy
why the
wins
universe is so
decisively.
big and empty.
As a result,
The
voids
vast distances
expand
between
faster
stars
than the
act as
rest of the
buffers.
universe.
It
They
keeps
grow
the
like
zones of the game
pushing their
separate, so the
boundaries
engine doesn't have to
outward,
render
while
everything
the
at
filaments
once.
of galaxies around
We are
them
not looking
act
at a
as
law of
rings.
nature.
This
We are
creates
looking at a hardware
self-reinforcing
bottleneck.
cycle.
And the
The
system
more a
uses
void
other tricks to save
expands,
memory.
The emptier
Remember the
it
double
becomes,
slit experiment?
which allows
The
even
particle only
faster
decides to be
expansion.
real
Scientists
when you look at it.
confirm this
That isn't
through
magic.
Careful observation.
That is
They measured
optimization.
how galaxies near
In a video
void
game, the
edges
computer
move
doesn't render the
compared
room
to
behind you.
galaxies in
It
denser
only renders
regions.
what is on the screen.
The void
This
galaxies
technique is
are
called
rushing away
frustum
from the
culling,
center
or
faster than cosmic
foveated
expansion
rendering.
alone would explain.
Quantum mechanics suggests
Something
our
is
universe
pushing them
does the
outward.
exact same thing.
That something
It
is the
leaves the
gravitational
unobserved
pull
world in a
from all the
fuzzy,
matter
low-resolution
outside the void.
state,
Think
waves,
of a void
to save
as a
RAM,
valley
and
surrounded
only
by
renders the
mountains.
high-resolution particles
Gravity pulls
when a
downhill
conscious
from the
observer
mountains
points a camera at
toward
them.
the valley.
We are
But since
living
we are
in a
talking
game
about
that is
space
optimized for
rather
the
than
player.
terrain,
But
that
who
pull
is the
makes
player?
galaxies fall
This
outward,
idea that the world
not
is
inward.
not there until
The
you look at
effect
it
is
sounds like
measurable and
philosophy.
significant.
It sounds sounds like something
Our
you
own
talk about in a
galaxy
dorm
is
room,
moving
not a
away
lab.
from the local void
But in
at
2022,
600,000 miles per
the
hour,
Nobel Prize in
driven
Physics
by
was
this
awarded to
gravitational
3
imbalance.
scientists
The
Aspect,
interior of a void
Clauser,
becomes a
and
strange
Zeilinger
place for physics.
for proving exactly
Light
this.
travels through it,
They destroyed a
experiencing
concept
less
called
gravitational
local
influence
realism.
than light passing
To
through
understand
normal
why
space.
this matters, you have
This
to
affects
understand what
observations in subtle
realism
ways.
means to a physicist.
When astronomers study
It means
the
that
cosmic
objects have
microwave
definite
background
properties whether you are
radiation,
looking at them or
the
not.
faint afterglow
It means the
of
moon is
Big
there,
Bang.
and it
They
weighs
notice
exactly
that
what it
light
weighs,
passing through voids
even if everyone on
appears
Earth closes
slightly
their
cooler.
eyes.
The reduced
Einstein
gravity
believed in
voids
realism.
causes less
He hated the
gravitational
idea that the
redshift,
universe was fuzzy,
showing up as cold
but the
spots
Nobel
in
Prize
temperature
winners
maps of
proved
the
him
early
wrong.
universe.
They demonstrated that
These cold spots line
subatomic
up
particles do
perfectly
not
with
have
where
fixed
we
properties
observe
until
large
they are
voids
measured.
today. This alignment
Before the
is not
measurement, they don't just have unknown
It is
spins. They have no
Understanding
spin.
what makes voids empty
They are not physical
helps
objects.
explain why they
They are
matter
lists
so
of
much to
potentials.
cosmology.
This
They
means
are
that
not just
realism
boring
is
blank
dead.
spaces between
The universe is
interesting
not
galaxy
locally real.
clusters.
The physical world
They
does
are
not exist in a
laboratories where
definite
dark
state
energy
independent
dominates
of the
and where
observer.
gravity takes a back
So
seat.
when the physicist
By
David
studying
Mermin
how
asked,
matter behaves
"Is the moon
differently in
there when
voids
nobody
versus
looks?"
dense regions,
the answer from modern
scientists
physics is a
contest
terrifying
fundamental
no.
theories about how
The moon
universe
is a
works.
probability wave.
The KBC
It is a
void
set of
around
coordinates
us
waiting
might
to be rendered.
unsettling,
It
because
only
makes
becomes
us
a rock
question our cosmic
when a conscious
typicality.
mind interacts with
But
it.
it also offers
This
a rare
implies that we
opportunity.
have the
We are
relationship
positioned
backwards.
in exactly the
We
right
usually
place
think that
to
the universe
study
is the
the
stage
universe's most
and we are the
extreme
actors,
low-density
but the data
environment.
suggests that
The
we are
structure
the
that
projector.
contains these voids
The stage is
is
dark
far
until we
stranger
point
than
our eyes
anyone
at it.
imagined.
But if the universe
is not
relies
a
on an
smooth
observer
soup
to
of
exist,
evenly
and if
distributed
you are the
galaxies.
observer, what kind of
Instead,
responsibility
it
does that
resembles
put on your
Swiss
shoulders?
where
If you
dense
accept the
matter
physics
forms
of the
walls
observer
and
effect,
filaments
you have to
surrounding
accept a new
enormous
definition of
hollow
what you are.
pockets.
You are
This
not a
foam-like
biological accident
architecture
crawling on the
is
surface of a
called
rock.
The cosmic
You
web,
are the
and
rendering
it
engine
represents
of reality.
The largest structure
Think about
in
the
nature.
computer on your desk.
Galaxy clusters
The hard drive is
concentrate
full of
at the
data,
intersections where multiple
photos,
filaments
movies,
meet,
games,
creating nodes of intense
but without a
matter
monitor,
density.
that data is
These
invisible.
nodes shine brilliantly.
It is just
with
magnetic
millions of
patterns in the dark.
galaxies packed relatively
It takes a
close
screen
together.
to turn those patterns into
Stretching
light.
between them run filaments.
It takes a processor
long
to turn the
chains
code
of
into an
galaxy
image.
groups that can
You
extend
are
for
that
hundreds
processor.
of millions of light
The
years.
universe is a
These
hard drive
filaments
full of
form
quantum
walls,
information.
vast
It is a
sheets
swirling
where
chaos of
galaxies
waves.
gather in
It has
higher
no
than
color,
average
no sound, and no
concentrations.
texture.
Between the
It is
filaments
just
and
math.
walls lie the voids.
Your brain is the
taking
machine
up
that
most
reads
of the
that math
volume
and
while
converts it
containing
into
hardly
blue
any mass.
sky,
This
cold
structure
water,
was not
and hard
always
floor.
obvious.
You
For
are doing this
decades,
work every
astronomers
millisecond of every
photographed
day.
the sky
You are
and
knitting the
counted
quantum soup
galaxies,
into a
but
solid
the
world.
true three-dimensional
This means that you are
arrangement
holding the
remained
universe
hidden.
up.
Distance
Without you,
measurements were poor.
The simulation goes
Galaxies
dark.
that appeared next to
Without
each
a
other
witness,
might actually
the
be
event of
separated
the Big
by
Bang
billions
is
of
just an
light years,
equation that never
with
gets
one much
solved.
farther away than
You
the
are
other.
the mechanism that
Only
allows
when
the universe to be
scientists
real.
began measuring
This
galaxy
turns your
redshifts
life into a cosmic
systematically
duty.
in the
It means that your
1970s
perception is the fuel
and
that keeps the
80s.
engine running.
Did the cosmic
But
web
this creates a
reveal
problem of
itself?
scale.
Redshift
If you are the
surveys
generator of
allowed
reality,
astronomers to
and I am the
calculate
generator
how
of
far
reality,
away each
how do we
galaxy was
coexist?
by measuring
Are we
how
generating
much
the
the
same
expansion
world,
of space
or are we
had
trapping each
stretched
other in a
its
hall of
light
mirrors?
toward redder
If we follow
wavelengths.
the logic of consciousness
Suddenly,
causes
the
collapse,
distribution
we hit a
snapped
wall.
into focus.
If I look at a
The
particle and
universe
see
had
up,
structure on
and you look at the
scales
same
nobody
particle and
expected.
see down,
The first major
who is
void
right?
discovery came in
We established with
1978,
Wigner's friend
when
that we
two
can both be
independent
right in our
teams
own
identified
bubbles,
large
but we still
underdense
manage to talk to
regions.
each other.
More
We still
surveys
agree that the
followed,
sky is blue.
each mapping deeper
How is that
into
possible?
space and revealing
There is a theory
an
called
increasingly
cosmopsychism
intricate web.
that solves
The
this by
slow
removing the
digital
separation
sky
between
survey,
us.
which began
It
in
suggests that there
2000,
are not 8
created
billion human minds on
spectacular
Earth.
three-dimensional
There is only
maps
one mind.
spanning billions
The
of
universe
light years.
itself is
These
the
maps
conscious entity,
show the cosmic
but to
web
experience
in
itself,
stunning detail.
it has dissociated.
Filaments twist and
Think about a
branch
person
like
with a
blood vessels.
dissociative identity
Voids
disorder.
appear as dark
Their mind
bubbles,
fractures into different
sometimes
personalities.
500 million
One
light-years
personality
across.
doesn't know what the other is
largest
thinking.
structures
They share the
include
same
the
brain,
Sloan Great
but they
Wall,
feel like
a
strangers.
filament nearly 1.5
Cosmopsychism argues that the
billion
Big
light-years
Bang
long.
was a
On
psychotic
the
break.
opposite end of the
The
spectrum,
one mind shattered into
supervoids
trillions
like
of
the
tiny
Eridanus
alters.
void
You,
stretch
me,
1.8
the dog, the
billion
bacteria.
light-years wide,
We are the
with
fragments
even
of a
fewer
single
galaxies
consciousness.
than the KBC
We look at each other and see enemies,
Together,
friends,
these features
and
paint a
strangers.
picture of a universe
But we are looking in a mirror.
organized on
When you talk to me,
scales far
you're talking
larger
to
than
yourself.
anyone predicted.
When you hurt
Galaxies
someone,
are not
you're
the
hurting your own
fundamental
hand.
building blocks.
The
web
separation
itself
is an
the
illusion
structure,
created by the brain
with
to
galaxies
keep the
just
game
marking
going.
where the matter happens
This
to
explains why the
concentrate.
laws of
Why
physics
does
are the
the
same for
universe
everyone.
organize
Because
this
we are
way?
all running on the
The
same
answer
underlying
reaches back
operating
to the
system.
beginning.
But it also
Immediately
reveals
after
a
the Big
terrifying
Bang,
truth about your
matter
identity.
was not perfectly uniform.
You are not a person.
Quantum fluctuations
You are a
during the
mask
universe's
worn by the
first
universe.
fraction of a second
And underneath that mask,
created tiny
you are totally,
variations in density.
absolutely alone.
Some regions
There is nobody
slightly
else here.
denser than average,
It is just you,
and others
forever.
slightly less dense.
But why would an
These
infinite,
differences were
all-powerful
minuscule,
mind choose
maybe
to shatter
one part in
itself?
100,000.
Why would it choose to become a
Gravity
fragile human who
amplifies
feels
even
pain
tiny
and fear?
advantages.
Why are we
Denser
here?
regions
If
pulled
we
in
are the
more
one
matter,
mind,
making
why
them
did we
denser
choose this?
still.
Why
Less
did we
dense
choose a
regions
world full of
lost
cancer,
matter to their
war,
surroundings,
and heartbreak?
becoming emptier.
Why didn't we stay in the
Over
bliss
hundreds
of unity?
millions of years,
The philosopher
this
Alan Watts
process
offered an answer
snowballed.
that chills the blood.
Small clumps
Imagine you
merged
could
into
dream
larger
any dream you
clumps,
wanted.
which merged
And in this
into
dream,
galaxy clusters,
you had godlike power.
which aligned into
You could fly.
filaments.
You could live for
Meanwhile,
1,000 years.
The underdense
You could have
regions
every pleasure.
expanded into
You would do
voids.
that for a while.
The cosmic web
But eventually
is
you would get
essentially
bored.
gravity doing its
Omnipotence
work
is
over
dull.
cosmic time.
There is no
turning
surprise.
barely noticeable
There is no
initial
risk.
ripples into the
So
grandest
eventually you would
architecture
choose
in
to dream a
existence.
dream
Today,
where you are not in control.
voids occupy roughly
You would choose a dream where you don't
90%
know
of the
what is
volume
going
of
to happen.
space.
You would
Filaments
choose a
and
dream
clusters
with danger.
make up the remaining
You would choose a
10%,
dream
but
where you could
contain
feel
most
pain,
of the mass.
just to
This
feel something
imbalance
real.
defines the universe's
Watts argues that
We
this
live
is
not in a
exactly what you are
cosmos
doing
filled
right
with
now.
Galaxies,
This
but in a
life,
cosmos of
with all its
emptiness,
struggles and
punctuated
fears,
by occasional
is the dream you
concentrations of
chose to
matter.
escape the
The
infinite boredom
KBC
of being
void
God.
is just one
We
bubble
fractured
in
ourselves
this
because
foam,
lonely
but it
eternity was
happens to be our
unbearable.
bubble,
We
and
accepted
that
the
makes
risk of
all the
suffering because the
difference for
alternative
what we
was the
observe
silence of the
and
void.
how we interpret
We built
the
this
universe.
simulation,
The next
filled it
chapter
with monsters
reveals
and traps,
exactly where we
and then
sit
wiped our own
inside
memories
this
so we
immense
could
hollow.
play the game for
The
real.
Milky Way is
We are
not
hiding
at the
from
center
ourselves.
of the KBC void,
But now that we have
but it
remembered
is
the
close
truth,
enough to matter.
now that we have seen the
Measurements
cracks
place
in
our
the
galaxy
stage,
somewhere
what do we
between
do?
200 and 400
we have deconstructed the
million
universe
light
down to
years
zero.
from the void's actual
We found the
center.
trapdoor,
That might
the
sound
leaking
like a huge
walls,
distance,
the rigged script,
and it is compared
and the
to
lonely god
anything
hiding in the
humans
basement.
experience.
Is there any
But
reason
the
to keep
void
playing?
extends outward
So, here is
for
the
a
full
billion
picture we have
light
painted over the
years
last
in
few
every
hours.
direction from
It is
its
not a
center,
pretty picture.
making our
We are
offset
living in a false
relatively
vacuum
small.
that could collapse
We
at any
sit
second.
well within the
We are being
underdense
dragged by a
region,
dark flow toward a
surrounded
gravitational
by the void's
monster.
low-density environment.
We are trapped in a
all
block universe where the
directions.
future is
This
already
position
written.
is not random.
We are
It has
simulations running on a
consequences
computer
for
with a
every
speed limit.
observation we make,
And underneath it
every
all,
conclusion we draw about
we are a
cosmology.
lonely,
If
fractured
we were
consciousness
located outside
hiding
the
from
void
the dark.
entirely, in
Logically,
one
the
of
correct
dense
response to this
filaments,
information
our measurements
is
of the
paralysis.
universe's expansion
If the universe
would
is a
look
rigged,
completely
hostile
different.
machine
We
that
would
is destined to
calculate a
delete us,
slower expansion
why
rate,
bother?
and the
Why
Hubble
get out of
tension
bed?
would not exist.
Why build a house
Our
that is going to
larger
burn?
cosmic neighborhood
Why love
adds
someone who
another
is just
layer to
code?
this story.
This is the
The
friction
Milky
point.
Way belongs to
Your
the
logical
local
brain
group,
sees the
a
futility.
collection of about
It sees
80
the math of the heat
galaxies,
death.
including
It
our
sees
giant
the error
neighbor,
codes.
Andromeda.
But your biological
The
brain
local group
refuses to accept
itself
it.
sits
You feel a
within the
drive.
Lania
You feel
Kea
hunger.
supercluster,
You feel ambition.
a massive
You
structure
feel the need for
containing
meaning.
roughly 100,000
This is the cruelty of our
galaxies
design.
spread
We are
across
meaning-seeking missiles
520
launched
million
into a
light
meaningless
years.
void.
Lania Kea
We are
is
programmed to look for
enormous by
patterns
any
and
normal
stories
standard.
in a universe
Yet
that
even
runs
this
on cold,
supercluster
in different
resides
entropy.
within the KBC
We are
void.
standing in front of a
Think
silent
about that for a
mountain,
moment.
screaming,
A structure
why?
containing 100,000
And the mountain is just being a
galaxies
mountain.
still counts
The philosopher
as part
Albert
of an
Camus
underdense
called this
region.
the
The void
absurd.
is so vast
The conflict
that it
between
can
our desire for
swallow
significance
entire
and the
superclusters
universe's
and
absolute
still
silence.
have room to spare.
Most people break
Lania
under this
Kea
pressure.
forms part
They
of the
invent
sparse
fairy tales to
population of
pretend the
matter
mountain
scattered
cares.
through the void.
But we have seen
One of
too
the
much
rare
physics to lie to
concentrations
ourselves.
in an
We know the
otherwise
mountain
barren
doesn't care.
expanse. The
So,
local
how do
group
we
is
live in the
also
face of the
influenced
absurd
by
without
another
going
nearby
insane?
void
How
called
do we
the
find a
local
reason to
void,
continue when we know the
which
game is
distinct
rigged?
from,
The
but
answer lies in
connected to
flipping the
larger
board.
KBC
Camus
void.
argued that
The
there is
local
only
void
one really
extends
serious
about
philosophical
200
problem:
million light years
suicide.
and sits adjacent
If life
to
is
our
absurd
position.
and the universe
Our
is
galaxy
silent,
is rushing
should we
away
just
from
check
it
out?
at
Camus said no.
600,000 miles per hour.
He proposed a
pushed
third
by the
option between
gravitational
hope and
pull
suicide.
from denser
He called
regions
it
beyond.
revolt.
This motion
He used the myth of
separate from the
Sisyphus to
overall
explain it.
cosmic expansion.
Sisyphus was
It is
condemned
a
by the gods to
peculiar
roll a
velocity,
giant boulder up a
meaning
hill.
it results from
Every time he
local
reached the top,
gravitational effects
the rock would roll
rather
back
than the
down,
stretching of
and he had to
space
start
itself.
over.
These
It is the
peculiar
ultimate picture of
velocities
pointlessness.
complicate
It is a
efforts
loop
to
of
measure
useless
the true
labor.
expansion rate,
That is your life.
because they add
wake up,
extra motion
you eat,
on top of the
you work,
expansion signal.
You sleep,
Astronomers
and eventually
must
you die.
carefully account
The
for
rock
these local
always
effects,
rolls back down.
but inside
Entropy
a
always
supervoid,
wins.
those effects
But Camus
are
imagined
amplified
Sisyphus at the
and
bottom of
harder
the
to
hill,
separate
watching
clean.
the rock roll
The void's
away.
influence
And in that
reaches
moment,
even farther.
Sisyphus
When scientists
smiles.
measure the motion
Why?
of galaxies out
Because
to
he realizes that
distances
the
of
rock is his.
250 million
The
light
struggle
years,
is his.
they find
The gods
bulk
wanted to
flows
punish
that
him with
exceed
futility,
predictions from
but by
standard
accepting the
cosmology.
futility and keeping on
Entire
going, he
regions of
defeats
space
the
are
punishment.
moving faster
He
than they
turns the
should
prison
be,
into a playground.
flowing in
This is the
coherent
secret of
patterns
optimistic
driven by the
nihilism.
void's
If the
gravitational
universe has no
imbalance.
inherent meaning,
The
that means it
KBC
has no
void
inherent
creates
authority
a
over you.
large-scale velocity
It cannot tell you
field
what is
that
right or
affects
wrong.
everything
It
within
cannot tell you what is
Galaxies
success
are
or
not
failure.
just sitting in
It is
an
a blank
empty region,
page. The
passively
fact that the universe
expanding
doesn't
with the
care is the
universe.
only thing that
They are
guarantees your
actively
freedom.
responding to the
If there was a grand
gravitational
plan,
landscape,
you would be a slave to it.
accelerating outward
But since
from
there
the
is no
underdensity
plan,
toward
you
denser
are the
structures
architect.
beyond the void's
You
edge.
are the local
This
god of
makes our local
significance.
patch of the
In a universe
more
of dead
dynamic
rocks and cold
unusual
gas, the
than
only
calm,
place where
uniform
value
cosmos that
exists
standard
is
models
inside your
assume.
own head.
Our position
You are the
inside
generator.
The void
You don't
also
find the
affects
meaning out
what we
there.
can see.
You project it from
Light
here.
from distant
And this act
galaxies
of projection is
travels
not just a
through the
psychological
void
trick.
on its way to our
It is a physical
telescopes.
war against the
That
nature of
light
reality.
experiences less
To
gravitational
understand why your life is a
interaction than
rebellion,
light traveling
you have
through
to look at the
denser
second
regions.
law of
The
thermodynamics.
reduced gravity
This
creates
is the
subtle
dictator of the
effects on
cosmos.
the light's wavelength
It states
and energy.
that everything must move
Additionally,
from order to
the void
disorder.
itself
The universe wants to
influences
turn
the
complex
distribution
structures
of
into
matter we
dust.
observe.
It wants to
When
burn
we
your
look
house down.
outward from
It wants to
inside the
scramble
void,
your DNA.
we see the shell
It wants to
of
turn your
denser
memories into
materials
static.
surrounding us in
The
all
natural direction of
directions.
physics is decay.
That shell appears
but life
as a
does the opposite.
concentration of galaxy
Look at a
clusters
tree.
and filaments
It takes chaotic
at a
dirt,
specific
water and
distance
sunlight,
range.
and it
Beyond the
organizes
shell,
them into a
The
complex,
universe
structured leaf.
returns to more typical
Look at a
density.
human.
This
You take
creates an
random atoms of
observational
carbon and
bias.
nitrogen
We are
and
not
weave them into a
sampling
brain
random
that can write
location
poetry.
in the universe.
This shouldn't happen.
We are sampling from
In a universe
inside
sliding
one of
toward
its most
chaos,
extreme
life
features.
is swimming
Living
upstream.
in the void means living with
We
systematic
are
uncertainty
entropy fighters.
about how
Every time you
typical our
build
measurements
something,
really
every
are.
time you fix
Every
a broken
measurement
chair,
you have ever heard
every
about
time you
the
learn a new
universe's
fact,
expansion rate
you are
might be
spitting in the
wrong.
face of the
Not
second
because
law.
scientists made mistakes.
You're creating a
but
local
because we are
pocket of
measuring
low
from
entropy
inside
in a
a
high
cosmic
entropy
hole
world.
that distorts the signal.
You are stealing energy from the
problem reveals
void
itself
and
when
forcing it to make
astronomers use
sense.
different methods
This
to
makes simply
calculate
being
the
alive
Hubble
an act of
constant,
defiance.
the number that
You
tells
are a
us
glitch
how
in the death
fast
spiral.
space expands.
The universe
One
is
method
trying to
looks
erase
at
you
the
every
cosmic
single
microwave
second.
background.
The vacuum wants to
Ancient
collapse
light
you.
from when
The
the
radiation
universe
wants
was
to
just
mutate you.
380,000
But you are still
years
here.
old.
You are
This
holding your
light
shape.
encodes
This is not a
information
passive
about
existence.
the early
It is an
universe's
active war.
density and
We are
expansion.
the resistance movement against the
Scientists
heat
feed
death.
this data
And even
into
though we know that
cosmological
eventually the
models
resistance will
and
fall
calculate
and the
what
universe
the
will freeze,
expansion rate
the victory
should
isn't
be.
in winning the
The
war
answer
forever.
comes out to about
The victory is in
67
fighting the
kilometers
battle
per
at all.
second per megaparsec.
The fact that we can stand
That
up
means
and
for
build a
every
castle in the
megaparsec
sand,
of distance,
knowing the tide is
roughly
coming, is the
3.3
bravest
million
thing
light
a
years.
consciousness can do.
Space expands
And the best part
at
is, the
67
castle doesn't
kilometers
actually
per
disappear
second.
when the tide
The
comes
second
in.
method
In
looks at
physics,
nearby
there is a
objects
famous
with
thought
no
experiment called
brightness.
Maxwell's demon.
Specifically,
It imagines a
type
tiny
Ia
creature controlling a door between
supernovae
two rooms of gas. The
Cepheid
demon opens the door
variable
to let
stars.
fast molecules in
These objects
and closes
serve
it
as
to keep
cosmic
slow
measuring
molecules
sticks,
out.
because
By doing
astronomers
this,
understand
he creates a
exactly
hot
how
room
bright
and a
they
cold
should be.
room. He
By
creates
comparing
order
their
out of
actual
chaos just by
brightness
using
to their
information.
apparent brightness as
You
seen
are
from
that
Earth.
demon.
Scientists
You are a
calculate
machine that
their
processes
distance.
information to
Combining
create order.
distance measurements
When you
with
write a line of
redshift
code,
measurements
you
gives
are
the
arranging
expansion
electrons
rate
into a
directly.
pattern that performs a
This
function.
local method
When you comfort a
consistently
crying child,
produces
you are taking a
higher
chaotic emotional
number,
state
about
and regulating it
73
into calm.
kilometers per second
When
per
you paint a
megaparsec.
picture, you are taking random
difference
pigments
is
and forcing them
9%.
to represent a face.
Both measurements
These are acts of
encoded
in negative
incredibly
entropy.
precise,
You are
with
building
very
fortresses
small
of structure
error
in a
margins.
wilderness of
Both
noise.
should give the same
And while the
answer
universe will
if
eventually tear
cosmology
these
is correct.
fortresses down,
They do not.
for a brief moment,
This discrepancy
they stand.
is the Hubble tension,
And that moment is
and it
real.
has reached 5
The universe is
sigma
infinite in
statistical
size and time,
significance, meaning
but it is
there less
incredibly
than a
poor in
1
complexity.
a million chance.
Most of the
It is
cosmos
just
is just
random
empty
variation.
void or burning
The
plasma.
KBC void
Complex
explains
structures
why
like a
these
library,
numbers disagree.
a song, or a
When we
conversation
measure the
are
expansion
incredibly
rate
rare.
using nearby
They are the
supernovae,
diamonds in the mud.
we are measuring
By
within
creating
the
them,
void.
you are enriching the
void's
texture
low
of reality.
density
You
means
are the
less gravity
grabby
pulling
alien
back on the
that
expansion.
consumes the nothingness
Matter
and
from the
replaces it
denser
with
regions outside
somethingness.
the void
The grabby aliens theory
gravitationally
says we should be
attracts
afraid of the
galaxies within it,
species that
adding
expands,
extra output
but maybe
velocity.
we should be that
Galaxies
species.
appear to receive
Not to
faster
destroy,
than they would
but
in
to
a typical
cultivate.
region.
We have the
This
right to
inflates
impose
the
our
local
order on the
Hubble
chaos.
constant measurement.
We have the right to
We
be
are
the
not
gardeners of the
measuring
galaxy.
universe's true
And the
expansion
garden we
rate.
plant leaves a
We
root
are
system that
measuring
goes
the
deeper than
expansion
time
rate
itself.
plus the void's
We are
peculiar
terrified of
velocity
death
field.
because we
The
think it
effect
means
is large
erasure.
enough to
We
account
think
for
that when our
most
timeline
or
ends,
all of the
our
observed
story is
tension.
deleted from the hard
When
drive.
scientists
But
model
remember
how
the
a
block
void of the
universe.
KBC's
Remember the
size
loaf of
and
bread.
depth would affect
If
local
Einstein is
measurements.
right and the past,
They find
present,
it
and
could
future
boost the
exist
apparent
simultaneously
expansion rate
as
by
a solid
exactly the
crystal,
amount needed to
then
match
deletion
observations.
is
But
impossible.
here is where it gets
Nothing is
uncomfortable.
ever
If the
erased.
void explains
The
our local
dinosaurs are not
measurements,
gone. They are just in a different coordinate of the block. The Roman Empire is still burning in its slice of space-time, and you are still being born in yours. Your life is not a fleeting spark that vanishes. It is a permanent geometric structure carved into the four-dimensional architecture of the cosmos. Think of a vinyl record. The music only plays where the needle is touching. That is your now. When the needle moves forward, the song behind it falls silent, but the groove is still physically etched into the plastic. The notes are still there. Your life is a groove in the universe. It has a start point and an end point, but the curve itself is eternal. Even 1 trillion years from now, when the stars have burned out and the universe is a dark graveyard, the you of the 21st century will still be frozen in the crystal, laughing, crying, and watching this video. You are a statue made of time. The universe cannot destroy you, because you are part of its geometry. You are built into the wall. This changes the way you look at your actions. You aren't just passing time, you are carving your statue. Every decision you make, every kindness you show, every mistake you fix is a chisel stroke on the stone. You are deciding, right now, what shape your eternal segment of the block will take. Make it a shape you are proud of. Make it a groove worth playing. Because the signal coming off that groove doesn't stop at the edge of your life. It ripples out forever. Recall the Wheeler-Feynman theory we talked about in the retro-causality chapter. The handshake across time. Every particle sends a wave into the future. Every interaction broadcasts a signal that travels at the speed of light, rippling out into the void forever. You are a lighthouse. The light bouncing off your face right now will travel past the moon, past Mars, and out of the solar system. 1 billion years from now, those photons will still be traveling through the vacuum of intergalactic space. The gravitational waves from your movements will still be shifting the fabric of space-time, however slightly. You are changing the physical structure of the future just by being in it. In a chaotic system, this is the butterfly effect. A tiny change in the initial conditions, like you deciding to turn left instead of right, can amplify over time to alter the fate of a galaxy. We don't know the impact of our signal. We can't see where the wave hits, but we know that we are broadcasting. And if the grabby aliens theory is true, and we are the firstborn, then our signal is the only one ringing out in the silence. We are the first notes of the song. If we destroy ourselves, the song stops. But if we survive, if we build, if we send a signal of order and complexity, that signal will become the background radiation for every civilization that comes after us. We are setting the template. We are the ancestors that the future will look back on. They will look at the hawking points in their sky and try to decipher who we were. They will try to reconstruct the data from the holographic shell to see what we did with our time in the sun. So, do not be afraid of the silence. Fill it. Do not be afraid of the dark. shine. You are the statistical miracle that made it to the party against odds of 10 to the power of 120. You have already won the jackpot. The only question left is, what are you going to buy with the winnings? To understand the value of the winnings, you have to look at the math of your own existence. We talked earlier about the Boltzmann brain, the idea that in an infinite, chaotic universe, it is statistically easier for atoms to randomly assemble into a fake brain for 1 second than it is to evolve a real biological civilization over billions of years. The odds favor the fake brain by a margin of 10 to the power of 50. That is a 1 followed by 50 zeros. Now, add the grabby aliens odds. It is statistically unlikely for a civilization to arise this early in the cosmic morning. We should be sleeping for another billion years. Now, add the fine-tuning odds. The constants of physics had to be set to within a trillionth of a percent to allow atoms to bond. If you multiply all these probabilities together, the chance of you existing, right here, right now, in a biological body, on a stable planet, in a stable vacuum, is effectively 0. The calculator just says, error. By all the laws of physics and probability, you should not be here. You should be a cloud of gas. You should be a Boltzmann hallucination floating in the void. You should be dead dust in a sterile universe. But you aren't. You are breathing. You are processing information. You are defying the entropy of the universe just by sitting in that chair. This means you are the biggest statistical anomaly in the cosmos. You are a glitch in the thermodynamics. The fact that you exist is the most impossible thing that has ever happened. So, when you feel small looking at the stars, remember that the stars are easy. Burning hydrogen is simple. Being a conscious observer in a chaotic void is the hardest trick in the book. You are the exception to the rule. And you are made of the exact same material as the rule you are breaking. We often say, I am in the universe, like you are a visitor walking through a museum. You feel like a tiny object inside a giant container. But that linguistic distinction is a lie. The astrophysicist Neil deGrasse Tyson, following Carl Sagan, reminds us of the literal biological connection. Look at your hand, the carbon in your skin, the iron in your blood, the calcium in your bones. Where did it come from? At the Big Bang, the universe only made hydrogen and helium. It didn't make carbon. It didn't make the stuff of life. To make the atoms that allow you to think, the universe had to build massive stars. It had to cook those elements in nuclear furnaces for millions of years. And then, it had to blow those stars up. Every atom in your body was forged in the catastrophic death of a star that exploded billions of years before the Earth was formed. You are made of nuclear waste. You are the recycled debris of a supernova. This means you are not separate from the violent history of the cosmos. You are the direct result of it. You are the universe organizing itself into a shape that can look back at itself. When you look at the night sky, you aren't looking at external objects. You're looking at your ancestors. The galaxy is your body. The gravity is your skin. The separation you feel is just a trick of the mind. The cosmopsychism dissociation we discussed earlier. Underneath the illusion, you are the mechanism itself waking up. So you don't have to be afraid of the universe. That would be like your hand being afraid of your arm. You are the universe. And that gives you the authority to decide what it means. If you are the universe waking up, and if the grabby aliens theory is true, then you have a job to do. Remember, the theory says we are the firstborn. The galaxy is empty. The silence is waiting for us. This isn't a license to be arrogant. It is a burden of responsibility. If we are the first, that means there is nobody coming to save us. There are no wise elders to stop us from blowing ourselves up. There is no safety net. If humanity fails, if we destroy ourselves with nuclear war, or AI, or engineered viruses, we don't just kill ourselves. We might be killing the only chance for consciousness in this entire sector of the universe. If we are the nucleation point for life in the Milky Way, then the future of trillions of stars depends on whether we survive the next 100 years. We are holding the torch in a very dark room. If we drop it, the lights go out for eons. This changes the way you look at the news. It changes the way you look at politics. These aren't just squabbles on a rock. They are the growing pains of a baby god trying to learn how to walk before it falls off a cliff. We are the great filter. We are the ones who decide if the galaxy stays dead or becomes a garden. The silence of the night sky isn't empty. It is an awaiting canvas, and we are the only ones holding the brush. But the brush is heavy, and the clock is ticking. We are walking through a minefield of our own invention. We established that civilizations usually die young. This is the logic of the great filter. It suggests that there is a trap in the evolution of intelligence. As soon as a species gets smart enough to build starships, it also gets smart enough to build weapons that can sterilize a planet. We are standing at that threshold right now. We have had nuclear weapons for 80 years. We have had synthetic biology and AI for a decade. According to the Lindy effect, which predicts the life expectancy of systems, we are in the infant mortality phase of technological civilization. We are toddling around a room full of loaded guns. The reason the universe is silent might not be because we are the first to start. It might be because everyone else who reached this level pulled the trigger. They found a technology they couldn't control, and they filtered themselves out. This means that every year we survive is a victory against the odds. Every day we don't press the button is a triumph of wisdom over instinct. We are racing against our own incompetence. But if we can make it past this bottleneck, if we can survive the next few centuries, the math flips. Once we leave the cradle and spread to other stars, we become almost impossible to kill. The grabby phase begins. We become the immortals. So, the stakes of your life are not just about you, they are about getting the species across the finish line. You are the crew member on a ship that is navigating the most dangerous strait in history. Keep your eyes open. We have spent the last few hours tearing reality apart. We looked into the silence and found that we might be the monsters. We looked at our minds and found a cosmic illness. We looked at time and found a prison. We looked at the ground beneath our feet and found a simulation running on a dying battery. It is enough to make you want to curl up and hide. But the only reason these theories scare you is that you are making one fundamental error. You are still thinking of yourself as a victim of the universe. You are seeing yourself as a tiny, fragile thing trapped inside a giant, hostile machine. But physics tells us that there is no inside and outside. There is no boundary where you end and the universe begins. You are not in the simulation. You are the rendering engine that makes it real. You are not trapped in the block universe. You are the geometry that defines it. You are not afraid of the grabby aliens. You are the grabby aliens. The atoms in your hand are the same age as the universe. The electricity in your brain is the same force that lights up the thunderstorms on Jupiter. You are not a stranger here. You are the mechanism itself. You are the galaxy waking up, looking in a mirror, and frightening itself with its own reflection. So, when you feel the weight of the heat death, or the vertigo of the multiverse, do not turn away. Embrace it. That weight is just the feeling of your own scale. You are the only thing in the darkness that can feel, think, and create. You are the part of the universe that learned to tell a story. The void is silent. The math is cold. The future is uncertain. But you are here. You are the glitch that defies the entropy. And as long as you are watching, the lights stay on. So, do not let these theories paralyze you. Let them liberate you. If nothing matters in the long run, then you are free to decide what matters right now. If the universe is a blank canvas, then throw your paint at it as hard as you can. Live a life that is worth recording in the block universe. Build something that screams against the silence. Be the force that fills your corner of the cosmos with noise, art, and memory. We are walking a tightrope over a bottomless pit, but the view is spectacular. So keep looking up. Keep asking the terrifying questions. And remember, you are the statistical miracle that made it to the party. Enjoy it while it lasts. If you made it this far into the deep end, you are exactly the kind of person who belongs here. Most people turn back when the math gets dark, but you stayed. If this journey shifted your perspective on reality, hit the like button. It helps the signal reach other observers in the algorithm. I want to know what you think. Which theory keeps you up at night? Are we the firstborn monsters, or are we just brains floating in a void? Leave your verdict in the comments below. I read them to remind myself I'm not the only one staring at the ceiling. And if you want to peel back more layers of the universe with me, make sure to subscribe and ring the bell. We have a lot more blueprints to examine. Thank you for watching. With you was Acronium.